Hello folks. Some of you have asked for the code for my level editor that I made for the platforming game, which I've uploaded in the past. But since then, I've worked on it quite a bit more and made quite a lot of improvements. So I just wanted to do an update on it and to show the code for this new level editor. The first main thing is that it's now scrollable. So the games that you can make with this are not limited to just the visible game window. You can set as many columns as you want in it. The other thing is I've made it a little bit more user-friendly. So the tiles themselves are selected over here. I've just got them as a whole bunch of individual buttons. The tiles and all these images are open source, so I'll put a link to that in the description. They're not mine, I just downloaded them. But once you select them, you can just click and drag and pretty much just create a map. Right-clicking deletes everything. And at the same time, I've got this level counter up here, so the arrow keys change the level that I'm on, so I can load in some of the levels that I've created already. For example, this one is for the game that I'm currently working on, and you can see I can just scroll along and see the whole world. And likewise, I can just carry on through level 2 and level 3 and so on. So there are existing level editors available that are far better than this and more polished, but I just wanted to create my own one. So if you just want the code for this, then I'll put that in the description. Feel free to download that. But if you want to understand how I've coded it and how it all works, then I'm just going to go through the code just now. So I'll close this down and I'll start off with a new window. And as always, you just start off with your imports. So import PyGame, and then you want to start PyGame by initializing it. So we say pygame.init. So that's it kind of kicked off. The next thing is to create the game window, which is that screen that you just saw. So I need to define a few variables for it. I'll add a comment to say game window, and then I'll define the width and the height variables. So these are going to be constant, so I will do them in all caps. Screen underscore width equals 800 and screen underscore height is equal to 640. So these are just the sizes I picked for that one. You can adjust this just to base around your own monitor size. But remember, what I had there was the game window where you could click and actually create the map. But then I also had a margin area on the right hand side, which had all the individual tile buttons. And then I had a margin area on the bottom, which I had my load and save buttons. So I need to create a couple more variables for these margin areas. So I'll say lower margin, that was 100 pixels tall, and the side margin, that was a further 300 pixels. So now I can combine these when creating my overall display window. So to create this window, you have to assign it to a variable. In my case, I'm going to call it screen. And then you say it equals pygame.display.set_mode. And in here, you need to put in those width and height variables. So in my case, they're actually going to be a combination of the two. So my width for the overall window is going to be my screen width plus the side margin. And then my height is going to be my screen height plus the lower margin. So with that done, this is going to create just a blank PyGame screen. I want to give it a title, so I'm going to say pygame.display.set_caption, and I will call this level editor. So if I run this code now, it just pops up for a second and then just disappears again. And the reason for that is it's just running through the code from top to bottom, comes to the end, and that's it over. So although this is not a game, it needs to run in the same methodology. So that means that I need some kind of constant loop for everything to just stay on the screen and allow some kind of interaction. Typically, what I use for this is a while loop, which is based on a condition that is always true. So I start off with my condition, which is just a variable that I'm going to set to true. So this is a Boolean variable that I've called run. So I've said run equals true, and then I can say while run, which means that as long as the run condition is true, then everything that is indented within this loop is going to continue running. If I run this code now, it will just freeze up the game because it's always going to be stuck within this run condition. There's no way to exit it. So before I do that, I want to make sure that I have a way out. So things like mouse clicks, button presses, and even mouse movements are all events within PyGame. And PyGame has an event handler that allows you to iterate through all the events it's recording and look for any particular ones that you're interested in. To do that, I just use a for loop. I say for event in pygame.event.get, which allows me to filter through every one of the events and then look for a particular one. The one that I'm looking for is when I click the X button in the top right corner. So that means that I'm exiting the game or exiting the game window. That event is called PyGame quit. That means that I can say if event.type, so the type of event equals pygame.quit, all caps, then that means that that button has been clicked, therefore I can exit this game loop. So remember, this is running on the condition that this run variable is set to true. So it goes to say then if I set this variable to false, then that means that's going to kick me out of this while loop and it's going to end. So just to wrap it all up, at the very end, I just say pygame.quit. So note that this isn't indented because it's not part of the while loop. This line is only run once the while loop is complete, i.e. we've exited it. So I can run this again, and now you can see I've got my game window. It says level editor because I set that caption, and if I click the X, it closes out. So that's the basics of the game. That's kind of the basic structure put in place. Now I can start to actually add in some of the features. The first thing I want to do is put in a background. Although the level editor doesn't really need a background, it gives me a nice reference point of where I am because it scrolls as I move the map around. So to do that, there was a bunch of different images that I loaded. It looks like one picture, but it's actually a number of them overlaid on top of each other. Before my game loop, but underneath where I've created my screen, I'm going to have a little section which I'll comment off by saying load images. And within here, I'm going to start loading those images. The first one is called well, these are just variable names that I'm going to give to them, but they kind of match the name of the image itself. This one is called pine1 underscore img, and to load an image into it, I say pygame.image.load, and then I give it the location of that file. So in my case, I have all my images stored in a folder called img, and then within that folder I have another one called background. So you may have completely different folders. It all depends on where you're going to put these images. Lastly, I put in the name of the actual image, which is pine1.png. And at the very end, I put convert underscore alpha. That loads in my first image. Then I just copy this down and I change this to 2 because I had a pine2 as well. Then I copy this down a third time. Now I change this entirely to mountain. Make sure I change the image name as well to mountain. And then the last image was called sky. So change this to sky image, but the actual name is sky underscore cloud. And that's just because there were 2 variations of it. So with these loaded in, I can now start putting them onto the screen. But of course, until I do that, nothing happens. So if I run this code, they're in the memory, but they're not coming up on the screen. Because there's a few of them, I'm just going to create a function to allow me to draw them. So I'll say create function for drawing background. And these functions are created by just saying def for define and then a name of a function. I'm going to call mine draw underscore bg. It doesn't need any arguments, so I leave the brackets empty. And then after that, I can start putting these images onto the screen. So to put an image onto the screen, you first of all call the name of your game window, which in my case is just called screen. So I say screen. And then the function for putting images onto it is blit. And the first argument is the name of the image. Now I'm going to put these on in reverse order. So I'm going to start with the sky first of all. I'll say put on my sky image first. Then I need to give it an x and a y coordinate. So I'll put another set of brackets. The x coordinate is 0. The y coordinate is also 0. I want this to start in the top left corner of the screen. If I run this again, nothing's actually going to happen because although I've created the function, I have not called it. I need to come into my game loop and make sure that I call that function. So I say draw bg, but again, if I run this, nothing still happens. It is now calling the function and it is trying to display this, but what happens within the code is throughout this game loop, I'm going to be calling a whole bunch of different functions for updating things and drawing things on the screen. Once all of that is done, I want to tell PyGame to update the display. And I'm going to do that at the very end of my game loop, so it just does it once at each iteration. And the line for that is pygame.display.update. And once that is added, if I run the code again, you see that it takes those images, in this case it's only one for now, and when it gets to the very end of this while loop iteration, it takes all of the changes that I've made during that time, and then it updates the screen with them. Now that I've got my sky image, I can put the mountain over it. I'll come back up to my draw background, and the next one is going to be again screen.blit, but this time it's mountain image. Now the coordinates can't be exactly the same as the sky, so I still wanted to start on the left hand side of the screen. So the x coordinate is 0, but for the y coordinate, I'm going to actually start counting from the bottom of the screen. So that means I need to take the screen height, which is as big as my screen is, and minus mountain mountain underscore image.get underscore height. So this will just move the image up a little bit and basically just put it right at the bottom of the screen above the little margin. So if I run this again, you remember there was a margin down here, and now the mountain image is coming up. So now I'm just going to shift it up the way, and I'll shift it by 300 pixels. So let's run that again, and now you can see the mountains stacked up with the sky behind it. So that's kind of giving me that layered effect, and the next I'm just going to add on the two pine images. So I can just copy this line down and just change, indent that properly, and I just change this to pine 1 image. And then I just change this bit here to pine 1 image. And then for this corner, I want to offset it by a little bit less, so I'll put 150. Run that again, and now you can see that's layering over it as well. So last one, just copy this down and do the same again. Change this to pine 2. Change that to pine 2, and then I'm not going to offset it at all. So delete that, and now when I run it, you can kind of see I've now got this layered effect with my background coming in as I want it. So now that I've got that background, it's going to give me a reference point for when I move the map around. And that's what I want to add in now. I want to add in this scrolling ability. So before I do that, I need to define a few variables for the game or for this program. So before I've got my images loaded in, I'll create a new section here and I'll add a comment to say define game variables. And in here, at the moment, the only ones I want to add in are just related to scrolling. I'll say scroll underscore left equals false, and I'll explain all these as I use them, but at the moment I just want to define them to start with. And then scroll right equals false, scroll equals 0, and scroll speed equals 1. Okay, so that's them defined. I'll explain them now as I start to use them. The main ones are basically scroll left and scroll right. So these are my triggers for being able to scroll the screen. And that's going to happen when I press the left and right arrow keys. So I already have this section here where I take events. All I need to do is add in an additional event, which is looking for key presses. So this one, I'll just add in underneath. I'll add a little comment saying keyboard presses. And this is just the same way as I did before. Over here, I was saying if event type equals PyGame quotes. I was looking for a particular type of event. Now I'm going to look for a different type. So I still say if event.type equals, but this time it's PyGame.key down, all caps. And this just basically means that it's recording or it's looking for a keyboard press. So now if it's detected that, I need to know which key is actually being pressed, or rather I need to look for particular keys. The ones I'm interested in just now are left and right. I say if event.key equals pygame.k underscore left. So if I press left, then that means that I want the map to scroll left. So I say scroll left equals true. And then I can just copy this one down, indent that, and just change it to k underscore right. And here I'm saying scroll right equals true. Now I'm not, that's not indented correctly. There. I'm not wanting to flip them around in here. So what I actually want to do is add in an additional check. So at the moment, this is just looking for keyboard presses. But what that kind of means is that as soon as I press the left arrow key, this scroll left variable will be set to true. And then I'm just going to be stuck, i.e. it's always going to be set to true. I have no way of setting it back to false. But in reality, as soon as I let go of the left button on the, or left arrow key on the keyboard, I want this variable to be set back to false. And there's another type of event for that. So I just copy this down, add it in below. And this time the event is exactly the same, but now it's just key up. And so this means that I've released the key from the keyboard. Now all I need to do is change these to false. So if the key that's been released is the left key, then scroll left is false, and the same for right. Now that I have these, I'm able to actually add in the scrolling. I like to keep the event handler at the bottom of the code, so I'm going to keep that down there. And above this, I will add a little section where I'll say scroll the map. And in here, I'm just looking for these two triggers, scroll left and scroll right. I can say if scroll left is true, then I just want to change the scroll variable, which is going to be the one that actually controls how everything is offset. I want to change it by 5 pixels. So I want to reduce that variable by 5 pixels because I'm moving in the left direction. And then I say if scroll right is true, then I do the same thing, but I change that variable in the positive direction. So I increase it by 5. And now that I have these, so if I run the code, press the left and right arrow keys, nothing happens. But the only thing I've got on the screen so far is my background. And I can now use this scroll variable to move that around. So I come back up to my drawBG function. And what I have all of these drawn in with an x coordinate of 0, I can replace that with scroll. Put in scroll in here. And replace all of these with scroll. Run this again. And what will happen is that I'll be scrolling in the wrong direction. So at the moment when I press right, the whole thing does move over to the right, but actually I need to be able to inverse the scrolling. So essentially when I'm pressing right, the background is moving right, but I actually want the background to move left even though I'm scrolling right. So it's a little confusing, but I just need to make all of these negative. So I add a little minus sign at the start of them all. And now I'm able to scroll in the correct directions. So of course you can see that everything goes pretty messed up, and that's just because I don't actually have anything to draw on there. The background has nothing there, there's no image. So I need to fix that, and also I need to add in some kind of constant looping. So when I get to the right hand side, this image has gone off the screen, I need to keep adding it in behind it. So I actually need more of these images to be drawn on. So the first thing I want to fix is that background. I need to add a background color and just fill it in all the time. And for that, I'll just define some colors up here. So I'll say define colors. And the only one I need for now is green. So I'll say green is, and this is just it's not the actual RGB normal green. It's just one I played around with. And actually, while I'm here, I'll define a couple more. So white, 255, 255, and 255. And then red, I'll define, but I'll make it slightly changed. So it's actually going to be like this. So now that I have this, what I want to do is at each iteration of my background, before I draw the images, I want to just fill the background with a color. So my screen, my display window, dot fill, and then in here you put in the color that you want to use. And I want to use green. So if I run this code again, you can see now it's actually poking at the bottom there. I have this green background, and when I scroll this, you can see now what's actually happening is really just the background image is moving along. So now I want to add in more of these images on the right hand side so they always just loop over. And for that, I'm just going to add in a for loop here. So I can say in here for x in range. And so this range is just going to be however many times I want it to repeat. I'm just going to pick a number 4, for example, and I can increase or decrease that if I find that it's not enough. And I indent all of these, but now I need to know how wide these images are so that I can put next the additional ones next to them. So actually, before I even do this, I need to measure the width. So say width equals, they're all the same width, I believe. So I'll just say sky image and I'll say get underscore width. So that's going to give me a width for one of the images. That means that at each iteration, I can just multiply this x coordinate by the width. So at 0, it's not going to shift it over across, but at 1, it's going to move over by a width of an image. So here, just instead of just saying negative scroll, I'll actually add in another set of brackets. And in here, I'll take x, which is my for loop range, multiplied by the width. And I just need to add that in before every one of my scrolls. So I put that in here, and here, and here. And if I run this again, now I can keep scrolling to the right-hand side, and you see it's just the same thing. It looks kind of endless, but this is where my for loop stops. So I do basically have just the same images pasted one after another in this kind of sequence. Now on the left-hand side, I don't actually want this is my 0 point. So I don't actually want to be able to just keep scrolling over to here because there shouldn't really be a world map on that point. So I just need to add a little stop when I get to that point. And that's quite easy. I just come down to where I've got my scrolling. But for scroll left, I can add an additional check. And scroll is greater than 0. There you go. So now I can only scroll as far as the end of that screen. So it won't actually let me go past that game window. But one little feature that I want to add to this scrolling is to give it a little bit of a depth perception, is to make things scroll at a different speed. So at the moment everything moves together and it doesn't look that great, to be honest. So if I come back up to my draw background function, what I can do is add a little multiplier here. So I'll say minus scroll and I'll just multiply it by a value. So I'll say 0.5 for the sky image. So I actually wanted to scroll at a slower rate. And then for this one, I'll say 0.6. And basically, as I get closer, because remember, these are supposed to be in order of distance. So sky is the furthest away, and then Pine 2 is the closest away. It's closest to. So then this one I will multiply by 0.7, and this last one I'll multiply by 0.8. So that means that they're actually all going to be scrolling at a slightly different speed. And if I run this again and I scroll, it's still quite fast actually, but you can see that the mountain and the sky, they're all scrolling at different speeds. And I think I know why it's all going so fast. I haven't limited the frame rate of this. So to do that, I'm just going to set up a couple of additional variables. So I'll set my frame rate. I'll say FPS is 60, so that's what I want to limit it to. And then I'll create a clock. So I'll say clock equals pygame.time.clock. And now I can go into my main game loop, and right at the beginning, before I do anything, I'll just say clock.tick, and the frame rate that I want is FPS. So if I run this now, yeah, that's way slower. That's a lot more manageable. So now you can much more clearly see, it kind of gives you a 3D effect of everything scrolling on top of each other. It's actually very slow. I want to be able to scroll a bit faster than this because there's going to be times where I want to get from one side of the level to the other quickly while I'm editing. So that is why I want to add an additional check. I'm going to add an extra event key, and this is going to be the shift key. Now, because I'm looking at the arrow keys, it makes sense to use the right shift. So I'm going to say R shift. So if the right shift key has been pressed, I remember I had a variable called scroll speed. So I'll say my scroll speed becomes set to 5. And if I let go of R shift, then I want to reset it back to 1. So we just add another check here for my key up section, and we just set it back to 1. And now I can go up to my scrolling section where I'm actually controlling this scroll variable, and rather than just automatically increasing or decreasing by 5, I can multiply that by the scroll speed. So because normally scroll speed is 1, that means that this is always typically going to be 5, but whenever I hold the shift key, it's going to be multiplied by 5 again, so scroll at 25 pixels. So let's try that. So I scroll normally, hold shift, and everything moves a lot quicker. Now that I've done that, the next thing I want to do is draw on a grid, because at the moment I can't really tell what this is being split into. And remember, I'm going to be using this to create sort of tile-based levels. So I'm going to create a new function called drawGrid just underneath this drawBackground function. So I'll comment to say drawGrid, and I'll say define draw_grid. And again, this doesn't take any arguments, so we'll just leave that those brackets closed. And my grid is just going to be a bunch of horizontal and vertical lines. So I'm just going to use a loop for it. But before I can create this for loop, I need to know how many lines I'm drawing. So I need to define a few additional variables. And so I come back up to where I'm creating these variables, and just above these, I'm going to add rows. So this one's in capitals because it's fixed, it's constant. I'm going to have 16 rows. And then I want to know how many columns I'm going to have. So my max columns for this entire editor is going to be 150. So you can tweak this depending on the size that you want, but for the game I've made, I've used 150 columns. The other thing I want to do here is work out the actual size of these individual tiles. Now, I have a screen height, and I know how many rows I want to fit into that height. So it goes to say then if I just divide screen height by rows, that's going to give me a nice size for each of these tiles. So I say here, tile size equals screen height divided by rows, and I use floor multiplication here, division here. So I've got 2 forward slashes. It just means that I'm going to get an integer value as opposed to potentially a float value. So now that these are defined, I can go down to my drawGrid function and I can start adding these in. So first of all, I'll say vertical lines. So as I said, this is going to be a for loop because it's just going to be a whole bunch of repeating vertical lines. So I'll say for C in range, and my range just needs to take me all the way up to the number of max columns that I have. So I'll say max underscore calls, but remember, for loop, whatever you put in the range, it goes up to the value just before this. So I actually need to add on +1, and that will take me all the way to maximum columns. And then to draw anything onto the screen with PyGame, there's various commands. So you use pygame.draw, and then whatever you put after this is the shape it will draw. So you can put a rectangle or a circle, In this case, I want to draw a line. Then the arguments are going to be your display window, which is my screen, the color, which I've already defined as white, and then you have to give it a start and an end coordinate. So the start coordinate is going to be your x and y, and then for the end coordinate also an x and y, and it just draws a line between the two. Now because these are my vertical lines, the y coordinate is just going to be always from 0 down to screen height, but the x coordinate is going to be changing. So at each iteration of this for loop, the x coordinate has to be jumping over by my tile size. Because remember, tile size has already been calculated. That's just how big each individual grid square is going to be. So in here, I say C, which is my iterator here, multiplied by the tile size. That's my x coordinate, and then 0 for the y coordinate. So that's going to start at the top, and now I add my second one. So for the x coordinate here, it's going to be exactly the same because I just wanted to draw vertically down. The y coordinate is going to be my screen height. So that covers the vertical lines. Let's just copy all this down and do the exact same thing for the horizontal lines. Change that to horizontal. So now the range is different because I'm going across the way. It's my rows that I'm interested in. So this stays the same. I'm still drawing lines, but now it's the x coordinate that's going to be fixed because I'm going from 0 over to screen width, but the y coordinate is going to vary with this C variable. So it's just going to be C multiplied by tile size. So over here, I can also change this to go all the way across the screen. So screen width, and the y coordinate stays the same. That's C multiplied by tile size. Okay, so that function is defined. Now I just need to make sure that I actually call it within the game loop. So just underneath draw BG, I say draw underscore grid. And if I run this now, there you go. So I've got this grid coming up. There are some additional lines here because remember, this is iterating all the way to my maximum columns, which is 150. So it's actually drawing lines off the screen and into the distance all the way until the end. I will add a little panel over here because this is where my buttons are going to go. So you're not going to see these vertical lines, but essentially that's what's happening right now. So this is fine, but there's a little issue. As soon as I start to scroll, my grid stays where it is. And I don't want that because I want the whole world to move whenever I scroll. It's not really the background I'm interested in, it's the tiles that I'm going to be putting in here. So this grid also needs to scroll. And I've already shown how to do that for the background, so it's quite straightforward. I just do the exact same thing here. I say that for my tile size, I add in minus scroll. So basically, anytime I want something to scroll, I just add in this minus scroll value. So that's covered on the x coordinate of the vertical. And of course, the horizontal lines, well, they don't need to scroll because they're just going across the screen anyway. So if I run this again and I scroll to the right, you can see now the whole thing is scrolling. And these horizontal lines, it kind of looks like they're moving, but they're not. They're actually always just fixed. They're just growing across the screen width. But because the vertical lines are scrolling to the left, it kind of looks like these lines are chasing them. So that's it. I've now got this grid coming up. And so what I want to do next is actually start to load in some of these tiles so I can put them onto the map. Remember I had an area here which had a whole bunch of buttons, and these buttons were essentially just the images that I plan to use as part of this level editor. So the way I've done that, I have an overall tile map which I didn't make. I downloaded that. It's an open source tile map, and I'll link that in the description. And essentially I just extracted all of these squares from it. So each of these links onto the next one. And then I've just numbered them from 0 to 20. So that's how many different tiles that I have. And this just allows me to load all of these images into the code and then create buttons out of them, arrange them on the right-hand side here, and then that allows me to select what tile I want. So it's quite a simple system. And the thing to remember here is how many tiles there actually are. So because it starts at 0 and ends at 20, I actually have 21 tiles because you have to count the 0th one. So that's kind of important because I'm about to set up all the variables for it. So if we come back up to my variable section, there's a couple here that I need to add in. No, actually, it's just one. I just need to say tile underscore types equals 21. So I've got 21 different tiles, but of course, whatever game is being made with this, it was going to have different number of tiles. So this variable is going to be changing when you set up the level editor for it. But now that I have defined how many I have, it means I can load them all in. So remember, I have this section here for loading images. I just need to do the exact same thing now to load in all those tiles. Now, there was 21 of them, so I'm not going to type out 21 times pygame.image.load. I'm just going to use a loop, and the fact that they're numbered from 0 to 20 makes this very easy. When I load these in, I want to save them all into a list. So first of all, I'll add a little comment here to say store tiles in a list, and then I'll create my list called image_list equals square brackets with nothing in them to create an empty list that I can add into. And now I can iterate through. So I'll say for x in range, and this range is going to be the number of tiles that I have, or the number of different tiles. So this is where that tile types variable comes in. So I iterate through all of those tiles, and I just load them in one by one. I can say image equals pygame.image.load, so just the same way as I did up here, and then the directory or the location is img/. So same as here, but now instead of the background folder, I've saved my tiles within a subfolder called tile. You may save them somewhere else, so you just need to make sure you update this section of code if you do. But then the next thing is that they were all numbered. So for me to be able to access them, I need to be able to use this variable here, because this is going to go from 0 to 20. So it's going to go through all of my tile types. I just need to feed that in here. So the way to do that is I will use Python's formatting function. I will add an F at the beginning before my quotation marks, and then within the quotation mark just after this /, I'll add curly brackets, and inside I put X. So it just takes that variable, which is going to be an integer, and then combines it into this string. And then I just add .png. So what that's going to be doing now, if I bring this back over again, it's going to be going into my folder. I know this is in the same one, I've just kind of put this temporarily, img/tile, and then as it iterates, it's going to go 0 png, 1 png, 2 png, and so on. And this will allow me to easily just load all of these images in one go. So of course, once each individual image is loaded, I have to make sure that they're not too big or too small. Remember, tile size determines how big each of those points on the grid is. Or sorry, each of those squares in the grid is. So I want to make sure that each of these tile images fits it perfectly. So let's scale them. I'll say image equals pygame.transform.scale. And then the image that I want to transform is that image itself that I've just loaded. And then the scale for X and Y, or rather not the scale, but the size in pixels, is going to be tile size for the X and tile size for the Y. So it's going to be a square. It doesn't matter what the shape starts with. So it could end up getting a little bit squished or a little bit stretched, but that's not really that important. And then once that image is loaded, I need to make sure that I'm adding it into this image list. So img list.append, and then the image. So once this is all complete, I'm going to have this image list full of 21 individual images for these tiles. Okay, so now that all of these images are loaded in, if I run this code, nothing happens yet. I've loaded them into the memory, but not put them onto the screen. And I'm not going to blit them, because that's not what I want. I actually want buttons to be generated from them. I've already created a button class myself separately, so I need to import this button class. So I'll just say import button. I'm not going to go through the code of how to create these buttons, the actual button class just now. I already have a tutorial on it separately. So the main thing is it just imports the code for it, and it allows me to create instances of the buttons. So just underneath here above my main game code, I'll have a section called create buttons. And because there's going to be so many of them, again, I'm going to use a list. I'll say make a button list, and I just say button_list equals an empty list. Now I have to use a little counter here because I'm going to have too many of these buttons to display all in a row or on in a column. I'm going to split them up over a bunch of rows with 3 buttons in each row. So to do that, I need to have a couple of counters. The first one I'll say is button column. So button_col equals 0, and button_row is also 0. And now I can start iterating through the images that I have in my list. So I can say for I in range. Now remember, my image list is up here. So this just tells me how many, or sorry, this is how many images I've got within that list, right? It starts off with nothing, and then I fill it up with all of these different tile types. So I need to know how many images are in it. And to do that, I can just take the length of the image list. So say len img_list. I could also just use the tile types variable, same thing really, +1, but I'm just going to stick with this in this occasion. So that's going to tell me how many images are within that list. So that means that for each image, I can create a button. So to do that, I just assign it to a variable called tile_button. and then it's going to be from the button module that I just loaded. So I have to first of all say button to access the class, which is button again, but with a capital B. And then the button class that I've created takes a few arguments. So the first two are the X and Y coordinate. Now I want all of these buttons to start over past my working screen width. So to start with, for the X coordinate, I can say screen width. Screen width. So everything is offset by this amount to begin with. And then remember, I had these variables for button column and button row. Well, I want to use these to allow me to position the buttons accordingly. So button column is going to control where I am within my grid of columns, of buttons, sorry. So I can say 75 multiplied by button col. This kind of seems arbitrary, but I've played around with these numbers previously, so this is just what looks nice. And then for the Y coordinate, it's 75 times button row plus 50. So it kind of shows what's going to happen with these as I add in my increases for button column and button row. But if you play around with these, it's kind of obvious where they go and how they shift. And then the next argument is the image that I actually want for this button. So because I'm iterating through my image list, all I need to do here is access that list and then call the I image. So image I is the one that I'm at when I'm iterating. That's going to call the image, assign it to that button class. And then lastly, I had an argument for scale. So I don't want to scale these up or down. They're already scaled images, so the buttons are going to be scaled to the exact same size. Now that I have my first button created, I can add it into my button list. I say button underscore list dot append and tile underscore button. So basically, as it runs through this iteration, it's just going to keep making more of these individual buttons and adding them to the list. And each time it creates one, it's going to position it based on these variables button column and button row. So now I'm going to start increasing them. So as soon as I create one of these buttons, I want to shift the next one along. So I say button column is increased by 1. So the next button column here, for example, is the X coordinate. So the next one moves over by 75 pixels, and then the next one moves over by another 75 pixels. So they just keep moving with 75 pixels in between them. But of course, once I've made 3 of them, I want to shift down a row and back over to the left-hand side to start over again. So I just add that check. I say if button column is equal to 3, then increase my button row. So I'll move on to the next row down, and then reset the button column back to 0 so that we start again underneath. Okay, so that creates all of my buttons, but if I run this code again, nothing still happens. I'm not drawing anything yet, so that's the only bit that's remaining to do. So first of all, remember, I kind of just have all these lines over here. I want to clear this and add a nice little panel area. And for that, I just need to draw a big rectangle over it. I'll say draw tile panel and tiles. And then I add the command pygame.draw. Remember, I used this for the lines. Now I'm going to use it for the rectangle. The first argument is the game window. The second argument is the color. And then I need the rectangle sizes. So this is the X and Y coordinate and then the width and height. Now the X and Y coordinate, so it's going to start over at the end of my working area, which is my screen width, and at the top of the screen. So that's the X and Y determined. And then the width is just the size of that margin, which is my side margin. And then the height is the entire screen height. So I'll say screen height in here. And if I run this now, I now have this green area over here. So now that this is done, I can start drawing those buttons onto the screen. Now remember, those buttons were just stored in a list, which means that I can iterate through that list. I can say for I in button underscore list, and then because I'm iterating through the list, it's giving me individual buttons back. So I can call the methods that come with them. And one of the methods that I've added into my button class is a draw method. It takes the display window argument, which is my screen. And if I run this again, you can see now all of these buttons have been drawn. So they're not just being blitted. These aren't just images that are being blitted onto the screen. These are my actual buttons with some functionality. And the functionality here is within the draw method itself. So in that class, this returns a Boolean value. So whenever they're clicked, it returns a value of true. So I can actually say if I.drawScreen, and that allows me to take an action back from them. So I'll put a pass in here for now because the action that I want is to be able to select a particular button. So first of all, I'll add a little comment here to say choose a tile, and I need to define a variable here called button count and set it to 0. So when I'm going through all of these lists, or sorry, all these buttons in the list, and I come to click on one of them, I need to know which one it is that I've actually clicked on. At the moment, this for loop doesn't have a way of counting. All it's doing is just iterating through them one by one and not really keeping account of where it's at within that list. So I can quite easily add a counter to this by enumerating this section. So I add in here, enumerate, wrap that in brackets, and then I need to add in a second argument or second variable within my for loop. So that variable is going to be button underscore count, which is this variable that I've just reset to 0. Add a comma here, and now this dual variable for loop basically says it continues to iterate through the button list, assigning each of the buttons to this variable I, but because I've enumerated it, at the same time it's keeping a count of where I'm at in this button count variable. So actually, I can demonstrate that by commenting this bit out and just saying print button underscore count. So if we run this, you can see it's just iterating through them constantly. So it's giving me a running counter, and I can use this counter to then pick a particular tile. So let's delete this and add this back in. So that means that if I'm getting a return on one of these tiles, remember this is iterating through all of them every iteration of the game loop. So if I click on one of them is going to then give me a true value here. So if it does, then I am able to tell which one it is by just saying current tile equals button count. So whatever it is, whatever this value reaches when I click one of these buttons, that's what the current tile is going to be set to. And before I actually use this, I need to make sure that I've assigned it up here. So we'll come up all the way to where I've got my variables and say current tile equals 0. So that just sets it to 0 and it defines it. Now that I have this, I can test this again to make sure that my buttons are working by saying here print current tile. Now this is going to just be 0 to start with because that's what I've defined it as. But if I click on one of these, you notice the numbers changed. So that's my 0th tile, 1, 2, 3, and so on until I get to tile 20. So that's it, the buttons are now working. What I'd like is a visual indicator that there's actually something here and I've actually selected one of them. So I'm going to draw a little red rectangle around the tile that I've chosen. So get rid of this print statement and instead I'll add a comment to say highlight the selected tile. And to do that, I just draw a rectangle. So again, I call pygame.draw.rect. It's going to go in the game window, so screen, then the color this time is going to be red. And then I need to put in here the rectangle that I want to draw. So I'm not going to manually define a rectangle because these buttons all have a rectangle of their own. So each of these buttons within the method has a self.rect variable. So that means that I can take the button from that list and then call its rect variable. So I know that my buttons are stored in a list, so I can say button underscore list, and then in here I can put the current tile variable. So that's going to tell me which button it is that I've selected, and then I can just type .rect, and that tells me or gives me the properties of the rectangle of that particular button. And lastly, because this rectangle will just be a solid fill, it will end up overriding the button. I don't really want that, so I'm going to add a border line here of 3. If I run this again, it's failed because what have I done? Oh, I've mistyped the screen. Run that again. Okay, and now straight away it's highlighted the first button for me. So now as I click onto the next ones, you can see it's just moving that highlighter around and it's just selecting the rectangle or the button that I've got. Okay, so that's really starting to come together now. The last main thing to add in, or the next main thing to add in, is to allow me to actually put these tiles onto the map once I've created them. So once I've clicked one of these, I want to be able to click on the map and be able to put it down. So to do that, there's a few different stages. The first stage is I want to know where the mouse is. So I need to get the mouse coordinates. Then I need to work out relative to this grid system, which grid point I'm in. And then I just need to assign that number of tile into it. So remember, these are numbered from 0 to 20. So it goes to say then I can just store that number within each of these points, and then that's going to allow me to draw them in the exact same ways I've drawn the buttons. So first of all, to explain how this tile or how this world map actually works, I'm going to bring up one of the levels that I've created for my game. Now you can see at the moment it just looks like a whole bunch of numbers, but actually these numbers correspond to these tiles. So when I said earlier this has 16 individual rows, so there's 16 of these little grids down the way, well, that's exactly the same way that this is laid out. There's 16 lines going down the way, and there's the same number of columns going across the way, so 150 going across the way. So this matches up with this grid here, and each of these numbers corresponds to a particular tile. In my case, I've chosen -1 to mean empty, not 0. So -1 shows that I have nothing within that tile. But then you can see as I go down, it's actually changing numbers. And each of these numbers corresponds to a particular tile from this selection. So 0 means it's this dirt or this ground tile. And you can see I've got a whole bunch of zeros here. So all of these are my ground tiles. Then 4, for example, corresponds to this tile here. So you can tell that that one at that point is going to change. And so on. Basically, that's what this tile map does. It stores all of the information from this grid into a file like this, which just has all these ones, zeros, -1s, and each one of those numbers corresponds to these images going from 0 to 20. So then when the game actually loads the file into it, it reads this file, reads this document, it goes through it item by item, and it says if it's a -1, it doesn't do anything, but if it's a 0, then it loads image number 0. If it's a 4, it loads image number 4, and so on. And that's how it builds up the entire map just from these images. But before I get as far as saving it as a file, how do I actually handle all of this data within Python? Because this is a massive amount of numbers. It's 16 multiplied by 150. So to do that, I just have a list that contains all of these numbers for me. So let's set up that list now. I begin that right at the top before my main game loop. So where I've got my colors defined, but just above my functions, I'm going to create my empty tile list. So I'll say create empty tile list, because of course you want to start off with a blank slate. So I'm going to call this world_data, and to create an empty list, as before, you just type in square empty brackets. And now this list is going to be made up in 2 layers. So it's actually going to be a list of lists. It's essentially an array because it is 2-dimensional, right? There's a whole bunch of rows, but then the overall list contains all of these rows. Each row itself is a list. So first of all, I want to create a list of a row. Now, because I have nothing to start with, so all of my numbers are just going to be -1s, I can create a list that just contains a whole bunch of -1s, or going all the way across. So I know that across the way I have 150 columns, so I can just create a list that contains 150 times of -1s. And to do that, that's quite straightforward. We just create a row, so I'll just say r equals a list that contains -1 in it, multiplied by my maximum number of columns. So that's that max calls variable. So this is going to create a standalone list with a -1 repeated 150 times. So just to demonstrate that, let's say print r, run this, and I can see there's just a list here, and it actually spans over a few lines. Starts off here, and it's just got 150 -1s. So what I want to do now is combine all of those into a master list, because that is just one row. But remember, I have 16 of them. So I need to iterate through all of my rows, create one of these long rows, and add them on. And let's add a for loop to do that. I'll say for row in range, which is my number of rows. For each one, I want to create one of these long -1 rows, and at the very end, I want to add that on to my world data. So world data.append r. So now I'm going to end up with a massive list that contains 16 rows of -150 -1s. If I demonstrate that, I'll just say print world_data, and you see what's happened here. Actually, at the end, it's got double brackets because it's showing me that I have a list within a list. So I can scroll this for quite a while, and you see it's just going to be a whole bunch of -1s. But if I was to output this to a CSV file, it will look just like this, but it'll just be all -1s. So that's fine. That's now created my empty list, and I can start adding tiles onto it. But what I want to do is basically start off with the assumption that I'm always going to have a ground. So I don't want to just have a completely empty list. I actually want the very last row to be a bunch of zeros, because that's what my ground tile is. And I can access that within my list. So I can just go to the very last row within the list, and instead of having -1s, I can change them all to zeros. So let's do that. Let's get rid of this bit. and let's say create, oops, not like that, create ground. I'll say for tile in range. So I'm going from 0 all the way to my max columns because I want all of them to be zeros. I access that world underscore data list, but I need to access only the last row. So I can say rows -1, so that'll give me the last one. And then the second index is going to be tile. And I'm just going to set them all to 0. So if I run this code again, oh, actually I need to add that print statement back in. I'll say print world underscore data. Remember, this was just all -1s all the way down to the bottom. But if I run this again now, I now have a whole bunch of -1s, but the very last list, you can see it starts here, is a bunch of zeros. So when I come to show it now, which I'll do next, it's going to give me an empty world, but it's going to have a ground running down here automatically generated for me. All right, so the last bit now is to draw these these tiles onto my world map. So I'll add a new function, say function for drawing the world tiles, and we'll say define draw underscore world. So for this is going to be a little bit difficult to explain, but basically I'm going to have to iterate now with a for loop through all of these items in the list. So every single one of these tiles needs to be looked at. I need to look at what number is in it, and then draw onto the screen the corresponding image that matches up with that item. Remember, all of my images are loaded within this image underscore list. So all I need to do is find out what the number is, and then access the correct image from that list. So that part's quite straightforward. But first I need to add in a couple of for loops to iterate through everything. So first of all, I'm going to iterate through my rows. So I'll say for, and remember I need to enumerate this because I need to be able to count where I'm at within these lists, because that's going to give me a sort of grid position. So I'll say for y row in enumerate my world data. So as I iterate through the world data list, it's going to give me a variable called row, which in itself is going to be an individual list. But it's also going to count where I'm at. So it's going to start off and it's going to count every time I move on to the next row. And that means that when I come to drawing them, I'll know which row I'm at within this grid. So I know vertically where to draw each one. Now I can iterate through each of these rows to look at each individual tile. Say for x, comma, tile in, I need to enumerate again, enumerate row. And here, I don't want to look for every single one. I only really care about anything that's above or greater than or equal to 0, because remember, -1 is just an empty space. So I'm ignoring the -1s. So I say, if that tile variable is greater than or equal to 0, only in that case do I want to try and draw something onto the screen. So I can draw onto the screen by saying screen.blit, and then the first argument is the image that I want to blit. Now, like I explained, my images are all stored in this image list, so I need to access the correct number of them, and that's already stored here. So if this was anything other than -1, say it's a 0, it's going to take the image that corresponds to index position 0. But now we need to give it an x and a y coordinate. And this is where these enumerators come in handy. So I know that for my x coordinate, this is counting where within the row I'm at. So it starts off at 0, then it moves on to 1, 2, 3, 4, 5, and so on. So this x coordinate is going to tell me how far along within the grid I'm going. So I can use that for my x coordinate. But I need to also multiply by my tile size, because this is just going to be individual numbers. It's going to be 0, 1, 2, 3. My tiles are sized in a number of pixels. So if I multiply that by tile size, then it's going to put all of these tiles side by side by the exact width of them. And lastly, remember, I need to make sure this also scrolls when I move. So I add in my negative scroll variable. So that's the x coordinate taken care of. I do the exact same thing for the y coordinate. It doesn't have to scroll, so I don't need to add that variable there. And now let's just make sure that this is called within the main loop, otherwise it won't work. So draw underscore world. So after all of that, we should be able to get a world map. So there you go. I have my little, my little ground set up here. So you know that it's working because my list was basically an empty list, but I changed the very last row to all number zeros, which is this tile here. So you can see now it's setting up with the basic world map for me. So the next big thing to do is to take all of these individual selections take the mouse position and allow me to click on one of these points on the grid. Now that I have my world map list created, all I need to do is change the position, or sorry, change the variable within it to whichever number I'm currently on. Okay, and that's not too difficult. To do this, I'll just break it down into steps. The first one, I'll come just in between where I've got my event handler and checking for my scroll. First thing I need to do, a little comment, is say, add new tiles to the screen. So the first thing I need to do is get my mouse position. Get mouse position. So PyGame's got a function for that. We'll say pos, which is just going to be my variable for storing that position into pygame.mouse.get_pos. So that's going to give me my x and y coordinates on the screen. So now that I've got those, I can convert them into actual grid positions. So we'll say x equals, and then I can access the individual position. So pos is a list, and index 0 is the x coordinate, index y is 1 is the y coordinate. So pos 0 is going to give me the x coordinate of my mouse, but remember everything is scrolling, so I need to remember to add in my scroll variable. So we say plus scroll, and lastly divided by the tile size. So that means that, say my tile size, just for a round number, say it's 50 pixels. If my x coordinate is at 150 on the game window, well then that corresponds to tile size number 3. So this is an easy way for me to figure out what tile I'm in on the grid. And now I did the exact same thing for y. I say y equals pos, and this time it's 1, divided by, again, tile size. But remember, my game window overall, if I was to run this again, this is my sort of working area, but then I can't click outside. So my mouse can go outside of that area. I don't want to record those clicks because those are going to be relevant only to when I'm selecting a tile, for example. So I need to make sure that I'm only looking for clicks when my mouse is within this area. And this area is my screen width, remember, by screen height. So I need to first of all do that little check here. We'll say check that the coordinates are within the tile area. If position index 0, which is the x-coordinate, is less than screen width, and position 1, which is my y-coordinate, is less than screen height, then I know that I'm within that working area. So in that case, I can start looking for mouse clicks. And we'll just say it here. I'll just add a comment, update tile value. And to get mouse clicks, again, there's a function for that within PyGame, which is pygame.mouse.get_pressed. And this has different, again, it's a list and it has different index values. So the left mouse button is at index 0. So when I say 0, I'm basically saying if the left mouse button has been clicked, well then I want to be able to change the tile of that current grid. Now remember, I've broken up my tile position into these x and y variables. These correspond to where I'm at on that world grid, and that world grid itself is my world list, or sorry, my world data list. So I can access each of those positions. So I can look for what I've got in that position at the moment. Say if world_data, and then in here, remember it's a list of lists. So I can give it first of all the y index, which is my rows. So it's going to look at each individual rows. It's going to isolate the row that I'm in with this mouse position. And then I can give it the second argument or the second index, which is the x position that I'm in, i.e. the column that I'm in. So this basically tells me within that particular grid, if that grid value is not equal to the current tile that I've selected from my buttons list, and I've just clicked the mouse button, then I just need to assign that to that point. Oh, I indented that badly. Then that world data tile becomes my current tile. So, okay, I know that's maybe quite confusing to actually explain, but maybe if I run the code, I forgot my column there. If I run the code, what have I done? Oh, this is supposed to have brackets after it's a function. I run that again. Okay, So my X and Y coordinates from the mouse are constantly being taken and constantly being recorded. In fact, I'll add a couple of print statements just to demonstrate them. So in here, I'll just say print. If I print pause, I think that will show me. Yeah, okay, so this is showing me my X and Y coordinates. So if I go all the way up here, it's roughly 0, 0. And as I move the mouse across, the coordinates move with it. But that's not really much use to me, right? Because that's saying over here that I'm over at 778,248. That doesn't relate to anything that I've got. So that's why I divided by the tile size. So now if instead of that I print X and I print Y, I run this, now you can see it's actually corresponding to the tiles. So I'm in tile 0. So I'm printing X and Y first. So this is tile 1, 0, 2, 0, 3, 0, 3, 1, 3, 2, 3, 3. So it's allowing me a way of correlating those mouse positions into a position on this grid. And then of course this grid itself is related to that world data list. So each of these points is also stored within that list. That means that by taking these values here, I can access that exact position within my list and I can change that number. So right now I know that at this grid point, that number in my list is -1 because nothing is showing. And at this grid point, which is 715, you can see down there, 715, the value within that list is 0. So it goes to say then, if I click on anywhere within this list, I just change that value. So right now I'm at coordinate 910. You can see it down here in the bottom left. I'm at coordinate 910. By clicking with this tile selected, it just assigns that position within the list to that new number. I can change that now. So this is my current tile. Remember, whenever I click on one of these tiles, it changes the current tile variable, which I defined. So that's 0, 1, 2, 3, 4. So my current tile at this point would be 4. When I click here, for example, which is grid point 10.7, that changes my... Oh, that didn't work. Well, that's a poor demonstration. I've done something wrong. What have I done wrong here? Well, I'm guessing what I've done wrong is that I'm not actually showing the correct tile when I print it. So if I go back up to my my draw world. Okay, yeah, I made a bit of a mistake here. So when I'm going through my lists, I'm checking that if tile is greater than 0, I need to blit that particular image. But rather than putting 0 in here, I'm supposed to put tile. So that tells me what number is within that particular tile, and then it shows that corresponding image. So let's run that again and change this to the world. Yeah, there you go. So now it's working a lot better. So I can move this around and I can just click them wherever. I can change the ground that I had, but I have no way of deleting these. So that's the only other thing that I need to add in here. So I've already shown how to do this with a left click. I just need to do the same thing with a right click. So I just come down here and add a second if statement. If PyGame mouse.get_pressed. This time the index I'm looking for is 2. So this is a right click. It's not 1. 1 I believe is the middle mouse button. So if the right mouse button has been clicked, then I just want to reset that world data at position YX just back down to -1, because remember -1 means there's nothing there. So if I run this again and just choose these boxes, put these boxes down, and then I right click, and now I can just remove them. Now the other thing I added in earlier was a scroll, so I can actually scroll left and right, and you can see everything stays in its own grid position. It just keeps moving relative to the screen, but it stays where it should be. Although I think there is one check that I didn't add, and that is that I can just keep scrolling off the edge of the map. I added a limit to the left. Yeah, I haven't added a limit to the right. And that's quite easy. I know how many columns I have. I have 150 of them. So where I scroll over to the right-hand side here, I can just add an additional check. So I'll just make sure that scroll is less than a particular value whenever I do this. And I know how many columns I have, so that's max calls, multiplied by my tile size, to give me that value in pixels. But then of course, I still have to include my screen width itself. So I minus the screen width. So if I run this again and I just quickly shift over to the right hand side, when I get there, it should just stop and stop moving. There you go. So I can't go past that value, and this is me at the end of my world map. So the world editor, the level editor is nearly done. I've pretty much got all the functionality that I want to do in it. I can add in all of these players and enemies. I can pretty much do whatever I need with it. However, there's no way to get this data out of here. So I need a way of saving and loading all of this information. Now I already have buttons created, so I just need to create a couple more. And for them, I first of all need to load in their images. So I'll come up here where I'm loading the rest of my images, and I'll load one for my save button. So save underscore image equals pygame.image.load. Mistyped that, image.load. And then this one is within my img folder, and it's called save underscore btn.png. So then just remember to, oh, actually that's something that I missed here. So convert alpha, I need to make sure that I add that here as well. So whenever you're loading images, again, I don't know why this isn't an automatic thing, but you need to add it on at the end of your statements here. So the other one is my load image. So load image, exact same thing, but I just changed that to load button. And now that these are done, I've got the images, I need to actually create the buttons from them. So my section for buttons is down here, so I'll just add it in here. So I'll say save underscore button equals button dot button. So remember, this is the button module that I've loaded, and then that's the class that's within it. And then I just need to position them somewhere on the screen. So these are just sizes that I've already pre-picked. I just divide my screen width by 2, and then I had screen height plus my lower margin and minus 50. So I just I already set these up before. And then lastly, I need to give it the image, which is, oh, not capitals, save underscore image, that's the button image, and then I don't need to scale them. So again, I'll just use a scale of 1. Let's copy that down, and this time it's my load button. And it's all the same here, screen width, but I need to shift this over, so I'll give it another 200 pixels, and just need to change that to load image. Alright, but now they're not going to come up on the screen until I actually call their draw method. So let's come down here, and I'll just put it underneath here. I'll say save and load data. And for now, I'm not going to take any returns from them, so I'll just draw them onto the screen. I'll say save.button.draw screen, and then load button.draw screen. Just to make sure that I've positioned them in the right place and everything works. Yeah, there they are. So I've got the buttons sitting there, maybe a little bit too low actually. I could increase them up a bit. They don't do anything yet. I haven't added that section in. But before I do, I want to add in some text over here because I need to know what level number I'm dealing with. So I need an output here and a little display. So first of all, I'll define a variable for my level. I'll come up here and I'll say level equals 0. I don't actually have a level 0 within the game, but the reason I have this here is just in case you accidentally click on the save button too early. I haven't added in a kind of like a save warning to say, are you sure you want to override the file? So right now, if you were to click save and you had an existing file there, it's just going to overwrite it. There's no way of getting it back. That's just the way I have coded it. I haven't added in that functionality. So I have added this as a kind of a little safety check that I start off with a level called 0, and it doesn't really matter if I accidentally overwrite that one. But now to actually put text onto the screen, PyGame doesn't have a function for that. You have to create it yourself. So we'll come up here, and I've done this quite a few times in my other games, so you may be familiar with this already. It's a function for outputting text onto the screen. You're basically just going to take, well, I'll type it out first. So draw underscore text. And it's going to take a few arguments. So the text that I want, the font that I want to use, the color, and then the X and the Y coordinates for them. And actually, before I go too far, I need to define that font. So let's go up here and say define font. Font equals pygame.font.sys font. And remember here, the first S and then the F are capitalized. If you get that wrong, it's not going to work. The font that I've used is Futura. You can just choose wherever you like here. And then that's the size for my font. Right, so we come back down to here. And remember to add a colon there, indent. And basically all I'm doing is to draw text, you have to take the text information, the text string, convert it to an image, and then blit that image on. So first of all, let's convert it to an image. So img equals font.render, then the text that I want, true value here, and then text underscore color. So that is created. I can put it onto the screen with that familiar blit function. So I want to blit the image itself, and the coordinates are X and Y. So that's it. That function will allow me to put image onto my screen. So let's go down to the main game loop. So I've got my draw world. I'll add a little section here, and I'll say draw underscore text. So the first thing I want to show is the level number. So I'll say level and space. And in here, I want to add in that level number as a variable. So remember, I've done this before with curly brackets. I just need to put the F down here. So this accesses Python's string formatting functions. So I do that, add in curly brackets, and in here, I just type that level variable. So it's going to automatically add it into this string. Next thing was font, then the color, which I'll just go with white. What was after color? Oh yeah, the X coordinate. So I'll say 10, and then the Y coordinate. So I've already specified this, screen height plus lower margin minus 90. So that's going to show my level number. Let's load that up. Yeah, there you go. So showing level, and I just want to show some little instructions to say what to do. So I'll say draw. Actually, I'll just copy this down. Copy that down here, draw text. And now I don't need any of this anymore. I'm just changing it to just a single string. I'll say press up or down to change level. This all stays the same, but I just need to lower it down a little bit. So say minus 60. And there we go. So now I've got this information. Of course, I haven't actually coded that in. Pressing up and down does nothing yet. I want to be able to increase and decrease the level variable. So maybe let's do that first before adding in the save and load functionality. So that's just going to be done with these event handlers here, just like I've done it before. So pretty easy. Just copy this one that I've used for left. I'm going to do this above it, so I'll copy it twice. So the first one is K up. So if I press the up key, then we'll just say, we'll just say level is increased by 1. So level plus 1. And now we do the same thing for down. And now level is decreased by 1. But of course, what you may notice here is that that means it's going to go into a negative value. Don't want that, so I'll add a little check here to say and level is greater than 0. So only decrease the level number if it's already above 0. So you don't want to go into negative levels. You're just going to end up with silly level numbers. So let's run that again and press up, press down, and there you go. I can only go down as far as 0, and I can go up as many times as I want. Now, I didn't actually need a key up check for this because it's just a trigger. It's just an on and off. So if I hold this, nothing happens. I can hold it as long as I want. It doesn't matter. I just need to trigger the fact that I'm pressing it once or twice, and then it changes the level number. All right, so for the last part then, I need to add in a way of loading and saving data. So there's a couple of ways to do it. I'm going to show one way of doing it. And for that, I'm going to use the CSV module. So import CSV. Remember that file that I showed earlier, that notepad file, that was a CSV file. So you can open it in Excel as well. And it just shows all of these as individual grids. So all those numbers, those minus ones and zeros and stuff, they just go into this file. So this allows me to read and write to these files. So we come down to here where I've got my buttons, and from them, that's where I want to trigger a save and a load. So remember, these allow me to take some kind of action back. So I can add an if statement at the beginning of them, which will trigger the fact that they can be clickable. So if the save button has been clicked, then I need to save level data. Now, I'm not going to go into the full details of how all of this works. That's just like an entire tutorial on its own. I'm just going to explain what I've done. So we say with open, and then in here you want to put in the file name. So file name is going to be, in my case, I've saved them all as level underscore data. If you've seen my platformer tutorial, you'll actually be familiar with these. So level underscore data, but of course you need to know what level number you know, right? So it's level 1, 2, 3, 4. So again, curly brackets in here, put in the level variable and add in the F at the beginning. So now it's going to be level 0 underscore data, level 1 underscore data, and so on. Then we add a comma, then a second argument, which is just going to be a W, and that just means this is going to be for writing. So we're opening this file to be able to write to it. Then another argument here, new line equals, and nothing in there. Don't put anything in at all. And then lastly, as CSV file. So again, I'm not going into all of the details. I'm just typing out what I've used. So the next thing is you have to create your CSV writer. So we say writer equals CSV, which is that module that I just loaded in, dot writer to access its writer function. And then we call in CSV file, which is the one that I've just opened here, CSV file, and we add in a delimiter. So the delimiter is essentially what you use to separate each of your values. So remember when I loaded those lists, there was a whole bunch of negative ones, but they all had a comma between them. So that comma is what separates a value, and that's what tells you that the one value in the grid is different to the next value. So that's what's going to separate them all. Well, now that I've done this, I need to take all that data from my world data list and save it into this file. So I can't just dump a list into this. It doesn't work like that. So I had to iterate through each individual row within the list and then write that into the file. So I'll say for row in world underscore data, because remember, that's kind of how I structured it anyway. My world data list is a list of rows. So this will allow me to iterate through each individual one, of which I have 16. And then I say writer, which I've just created up here as my CSV writer, dot write row. So that's just a function that comes with the CSV module. Write row, and what do I want to write? Well, I want to write the row that I'm just iterating through. So when this is done, and when this all iterates through, it's going to create that file for me, and it's going to save it as level something.data, level underscore data.csv, and it's going to contain all of that information in it. So let's run this and just see what actually happens. I don't think I have it. Well, load button's not going to work anyway just now, but level 0 is kind of sacrificial. I'm not really worried about what's on there. So let's just mess about with this. I'll just create nothing just to demonstrate. So I'll just create a couple of these little blocks, maybe change the number, just so the file shows that there is some variation. So now that I've done this, let's save it. And there you go. I have no confirmation, nothing that tells you that something's happened, but I know that it's saved as level 0. If this file didn't already exist, it will create one, but if it was existing, it will just overwrite it. And now I can show you that file. So this is the CSV file that's just been created, level 0 underscore data CSV. So you can see there's my 16 rows, and then they go all the way over there for 150 columns. All of it pretty much is minus ones, which means there's nothing there. But notice what's going on here. All these zeros, if I just color code them, you remember this is exactly what I just drew up. I created a couple of kind of blocks, and then I put some water in there just to differentiate. So I've got these 10s and these 9s. So this is basically what it does. This is how that level editor works. You start off with a blank slate of just a bunch of negative ones. You change them to a different number depending on the tile that you've selected, and then you save it into the CSV file with a number that corresponds to whatever's in there. So loading this in is just the exact reverse. So we come back up here. I've got my load button, but I'm not taking any returns from it. So I can just say if load button, then that's going to make it clickable. Then I can start to load in the level data. So let's say load in level data. And the first thing here I want to do is reset my scroll back to the start of the level. Because remember, I could be moving, so let's pass this. I could be scrolling over to the right-hand side, but when I load, when I click the load button, I want the level to load, but I want the screen to start over on the left-hand side again. So that's why I'm going to reset my scroll to 0. And then it's actually more or less the same as this. I'm just going to copy this down so I don't have to retype it all. So again, the same thing. We open that file. The level number stays the same. And this time I just get rid of this because I'm reading the file now. I don't need to put anything in this place. Keep all that the same. Change writer to reader. And here as well. So there's now a CSV reader that we want. The file is the same. The delimiter stays the same. It's still a comma. And now I need to load the data in back the way. Well, this unfortunately isn't quite as straightforward because the CSV data is a bunch of strings. So what I was saving to it from my list originally is a bunch of integers. What I'm going to get back from it is a bunch of strings. So all those 1s and 0s and 9s and whatever I had in this spreadsheet, in that Excel file, when I load them back in, they're not going to come back as numbers to me. They're going to come back as strings. So I'm going to have to convert each one to an integer. That means that I can't just load them in a batch of rows. I have to go through each individual item. So that means that I have to iterate twice. So I'm iterating through my row, but remember, I have to also know where in the position of the list I'm at. So that means I need to enumerate again. So we'll say for X row in enumerate world data. Oh, not world data. No, we're enumerating through the reader because that's what I've just read in. So I'm reading this information back in and I'm going to save it into my world data. And then the next one is I now need to iterate through that row that I've just loaded in. So for y, tile in enumerate row. And this is going to give me each individual tile within that CSV data. So from that file, I'm going through each item one by one and saying what is within that file, or what is within that cell. And I'm storing that within my list. So my world data list at index position X and index position Y becomes an integer value. So convert that tile number into an integer, or that tile string. And that, I believe, should be it. Let's try that. So I've already saved my level 0. So let's just load it back in. And there you go. My level is loaded in. So if I go up one, this is going to load in the levels that I created before. And they all work in the exact same way. This is just all information from all of these tiles stored in all of these individual cell points. So that's one way to be able to save and load files, is to use this CSV module. But I don't think it's the best way. Well, it's definitely not my preferred way so far. Simply because in here it seems like I'm adding an extra step in between. So all of my information for this map is saved within this world data list. And then what I'm doing is taking that list and then kind of processing it and saving it as a CSV file. But to load it in, I then take that CSV file and I have to read through each individual item within that file and save it back into this list. So there's kind of like an extra step. I mean, it would be easier if I just took this list and just saved that list on its own. And that's basically what I did in my previous platformer. So I used the pickle module for that. And for those who are interested how that works, I'm going to show this alternative. So I import pickle, and it works kind of similarly to the CSV functionality for saving and loading, but it's just I find it a little bit easier. So I'm going to comment out the save and load just now, or just the method for CSV. So at the moment, there's nothing there for saving. I'm going to retype this using the pickle module instead. It's actually kind of similar, but instead I create a couple of extra variables. So I say pickle underscore out equals open, and then in here I want to just copy this because it's going to work in the exact same way. I have those level data files. So I format that, but I just delete this .csv because it's not going to be anything that you will be able to open with any program. It's just going to be a list, a Python list. So I do that, and then I add in comment here, WB. So that's opening it to allow me to write. Then the next line is pickle.dump. And what I'm dumping is the world data. So I'm dumping that list into my pickle underscore out. And then finally, I just need to close it. So I say pickle underscore out dot close. So I close that file that I'm working on. And that's it. So these 3 lines of code are going to save that file as a Python list. So rather than converting it, going to the bother of converting to a CSV, it just saves it like that. So let's just make sure I've done that. Actually, no, I want to load something in first before I overwrite it. So I'll do the same thing now. I'll comment out the section for loading with CSV, and I'll load with pickle. So in here we just say, well, first of all, I need to make sure that my world data list is reset because I'm about to load in a world data list. So I need to make sure that it's empty to start with. And then I say pickle in. So instead of pickle out, I now say pickle in equals, in fact, I should copy this down because it's pretty much the same. Open, put brackets around that. But now, instead of WB, it's RB. So now I'm reading. And now when I read it out, I can just save it straight into that world data list. So pickle.load, and what I'm loading is that pickle in, which I've just opened as my file. So pickle underscore in. And there you go. That's all. So I just needed these lines to be able to load that load that list back in without having to really convert it or do anything to the values. So now if I load in one of my files, so this was my level 0. There's my level 1. I don't know if I have a level 2, so I'm not going to check. But I can load in my level 0. I can mess around with it, save it, and then load another one, come back, and load it again. And you see, there it is. It's still all set up. It's working in the exact same way. What I would say, though, is these aren't interchangeable. So choose one and then stick to it, because once you made a CSV, you're not going to be able to, well, you can, but you're going to have to convert it back into a Python list using this kind of method. So those are the 2 ways you can do it. I'll leave both of them in the code, but I'd say my preferred is pickle, but what it means then is that you're not able to open the files up into this kind of nice CSV to see what's going on. So maybe that's a preference for some people, because then you could go in and manually tweak these numbers. I wouldn't recommend that, but I suppose it gives you a little bit more visibility of what's inside those files. Otherwise, you're not really getting anything from them when you just use pickle. It's a file that really doesn't mean anything. If you open it with, for example, with Sublime editor, it's just like a bunch of numbers and letters. It doesn't really mean anything to anyone. And that's it. That's how I made this level editor. I realize this video has turned out to be quite long. Hopefully it made sense, wasn't too confusing, and if you found this useful, then please do leave a like. And if you want to stay up to date with these kind of tutorials, then feel free to subscribe. Thanks for watching.